सब्सक्राइब कीजिए ये ट्यूटोरियल चैनल को और बेल आइकन को दबाइए सबसे पहले एजुकेशनल वीडियोस देखने के लिए। Hi everybody, this is Sanjay. Today I am going to teach you the first chapter from science subject from standard 9. So our first chapter is matter in our surroundings. So let's start. As we look at our surroundings, we see a large variety of things with different shapes, size and textures. जब हम अपनी सराउंडिंग को देखते हैं तो हम क्या देखते हैं? वैरायटी ऑफ थिंग्स डिफरेंट शेप में देखते हैं, साइज, टेक्सचर उसमें डिफरेंस होता है. Everything in this universe is made of a material which scientists have named matter. तो जो यूनिवर्स में एवरीथिंग इन दिस यूनिवर्स इज मेड ऑफ, जो यूनिवर्स में है वो मटेरियल से बना है जिसको साइंटिस्ट बोलते हैं मैटर. द एयर वी ब्रेथ, द फूड वी ईट, स्टोन्स, क्लाउड्स, स्टार्स, प्लांट्स एंड एनिमल्स, इवन ए स्मॉल ड्रॉप ऑफ वाटर और ए पार्टिकल ऑफ सैंड, एवरीथिंग इज ए मैटर. तो इन सारे चीज को हम मैटर बोलते हैं. We can also see as we look around that all the things mentioned above occupy space and have mass. तो ये सारे चीज जो बताया गया है वो स्पेस ऑक्यूपाई करता है एंड कुछ मास भी उसके पास होता है. इन अदर वर्ड्स दे बोथ मास एंड वॉल्यूम. तो उनके पास मास भी है और वॉल्यूम भी है. Since early times human beings have been trying to understand their surroundings. तो अर्ली टाइम से बहुत पहले से ही तो ह्यूमन बीइंग क्या करते थे, वो जो सराउंडिंग को समझने की कोशिश कर रहे हैं. अर्ली इंडियन फिलोसोफर क्लासिफाइड मैटर इन द फॉर्म ऑफ 5 बेसिक एलिमेंट्स. तो वो क्लासिफाई किए 5 बेसिक एलिमेंट्स, द पंच तत्व एयर, अर्थ, फायर, स्काई एंड वाटर. According to them, everything living or non-living was made of these 5 basic elements. Ancient Greek philosophers had arrived at a similar classification of matter. तो ग्रीक जो फिलोसोफर थे वो भी इस क्लासिफिकेशन के पास अराइव किए थे, मतलब पहुंच चुके थे. Modern day scientists have evolved two types of classification of matter based on their physical properties and chemical nature. तो जो मॉडर्न डे साइंटिस्ट है वो लोग भी दो तरह का क्लासिफिकेशन ऑफ मैटर किए हैं. मैटर का दो क्लासिफिकेशन किए हैं based on their physical properties and chemical nature. In this chapter, we will learn about matter based on its physical properties. Chemical aspects of matter will be taken up in subsequent chapters. Physical nature of matter. Matter is made of particles. For a long time, two schools of thought prevailed regarding the nature of matter. One school believed matter to be continuous like a block of wood, whereas the other thought that matter was made of particles like sand. Let us perform an activity to decide about the nature of matter. Is it continuous or particulate? You will do the activity. In order to answer these questions, we need to use the idea that matter is made of particles. What was there in the spoon, salt or sugar? How has now spread throughout the water. This is illustrated in figure 1.1. You can see in this picture. How small are these particles of matter? This experiment shows that just a few crystals of potassium permanganate can color a large volume of water, about 1000 liters. So we conclude that there must be millions of tiny particles in just one crystal of potassium permanganate, which keep on dividing themselves into smaller and smaller particles. The same activity can be done using 2 milliliters of Dettol instead of potassium permanganate. The smell can be detected even on repeated dilution. Characteristics of particles of matter. उसका characteristic क्या होता है? Particles of matter have space between them. In activity 1.1, activity 1.2, we saw that the particles of sugar, salt, datar or potassium permanganate got evenly disturbed in water. Similarly, when we make tea, coffee, lemonade, nimbu pani, particles of one type of matter get into spaces between particles of the other. This shows that there is enough space between particles of matter. So now particles of matter are continuously moving. From the above 3 activities you can read in your textbook, and 1.5 we can conclude the following. The particles of matter are continuously moving, that is, they possess what we call the kinetic energy. जो particles का जो move हो रहा है, continuously जो move हो रहा है, तो उसको हम बोलते हैं kinetic energy. The as the temperature rises, जब temperature rise होता है, मतलब बढ़ता है, particles move faster. जो particle है वो faster move करता है. So we can say that with increase in temperature, kinetic energy of particles also increases. In the above three activities, we observe that the particles of matter intermix on their with each other. They do so by getting into the spaces between the particles. This intermixing of particles of two different types of matter on their own is called diffusion. तो उसको हम diffusion बोलते हैं. We also observe that on heating diffusion become faster. तो हम observe करते हैं कि heating में diffusion becomes faster. Why does this happen? Next, particles of matter attract each other. Just try to do this activity. Okay, if we consider the above three activities, 1.6, 1.7, 1.8 suggests that the particles of matter have force acting between them. This force helps the particles together. The strength of this force of attention varies from one kind of matter to another. तो एक मैटर से और दूसरे मैटर को वो अट्रैक्शन वेरी होता है. States of matter. ऑब्जर्व डिफरेंट टाइप्स ऑफ मैटर अराउंड यू. तो जो आपके पास जो जितने भी सारे मैटर्स हैं उसको ऑब्जर्व कीजिए. व्हाट आर द डिफरेंट स्टेट्स, उसका डिफरेंट स्टेट्स क्या है. वी कैन सी दैट मैटर अराउंड अस एग्जिस्ट इन थ्री डिफरेंट स्टेट्स: सॉलिड, लिक्विड एंड गैस. These states of matter arise due to the variation in the characteristics of the particles of matter. Now let us study about the properties of these three states of matter in detail. The solid state. All the above examples of solid, we can observe that all these have a definite shape, distinct boundaries, and fixed volumes. That is, have negligible compressibility. Solids have a tendency to maintain their shape when subjected to outside force. तो जो solid है तो उनके पास tendency है एक maintain shape maintain करने के लिए जब उनके पास बाहर का कुछ force प्रयोग करते हैं. Solids में break under force. जो solids है वो force के तरह वो break कर सकते हैं, but it is difficult to change their shape. वो फोर्स के द्वारा उसका जो ब्रेक हो सकता है लेकिन उसका जो शेप है उसको हम चेंज नहीं कर सकते, वो डिफिकल्ट होता है. सो दे आर रिगिड. कंसीडर द फॉलोइंग. व्हाट अबाउट द रबर बैंड, कैन इट चेंज इट्स शेप ऑन स्ट्रेचिंग? Is it a solid? What about sugar and salt when kept in different jars? These take the shape of jar. Are they solid? What about the sponge? It is solid yet we are able to compress it. Why? All the above are solid. A rubber band changes shape under the force and regains the same shape when the force is removed. If excessive force is applied, it breaks. So the shape of each individual sugar and salt crystal remains fixed whether we take it in our hand, put it in a plate or in a jar. A sponge has minute holes in which air is trapped. When we press it, the air is expelled out and we are able to compress it. Then comes the liquid state. First is solid state, second is the liquid state. We observe that liquids have no fixed shape but have a fixed volume. They take up the shape of the container in which they are kept. ये जो कंटेनर में वो हैं वो उनका ही शेप लेता है. लिक्विड्स फ्लो एंड चेंज शेप. लिक्विड्स फ्लो होता है और उसका चेंज शेप भी जो शेप होता है उसको भी चेंज करता है. सो दे आर नॉट रिगिड बट कैन बी कॉल्ड फ्लूइड. वो रिगिड नहीं कहा जा सकता लेकिन उसको फ्लूइड हम बोल सकते हैं. We refer to activity 1.4, 1.5 where we saw that the solids and liquids can diffuse into liquids. जहाँ पे हम solid देखे और liquids देखे जो liquids हो सकते हैं. The gases from the atmosphere diffuse and dissolve in water. तो जो gases और atmosphere जो होता है वो diffuse होते हैं और dissolve in water पानी में मिल जाते हैं. These gases, especially oxygen, carbon dioxide, are essential for the survival of aquatic animals and plants. तो जो gases हमको मिलता है स्पेशली एक ऑक्सीजन एंड कार्बन डाइऑक्साइड वो aquatic animal के लिए और plants के लिए बहुत essential है बचने के लिए, जिंदा रहने के लिए. All living creatures नीड टू ब्रेथ फॉर द सर्वाइवल। तो जितने सारे भी क्रिएचर्स हैं और लिविंग क्रिएचर्स, उनको ब्रेथ करने के लिए, सर्वाइव करने के लिए उनको ऑक्सीजन या कुछ गैसेस चाहिए उनको। The aquatic animals can breathe under the water due to the presence of dissolved oxygen in water. Thus, we may conclude that solids, liquids, gases can diffuse into liquids. तो हम यहाँ पे conclude कर सकते हैं, give a conclusion, हम conclusion यहाँ पे दे सकते हैं कि solids, liquids and gases वो liquids हो सकते हैं। The rate of diffusion of liquids is higher than that of the solid. जो liquid का जो मतलब यहाँ पे बताया गया है, जो रेट ऑफ डिफ्यूजन ऑफ द सॉलिड इज हायर देन दैट ऑफ सॉलिड, मतलब लिक्विड का लिक्विड होना और सॉलिड से लिक्विड होना उसमें हाई रेट होता है। दिस इज ड्यू टू द फैक्ट दैट लिक्विड स्टेट particles move freely and have greater space between each other as compared to particles in the solid state. तो सॉलिड के स्टेट में जो पार्टिकल्स होता है उसमें जो स्पेस होता है वो थोड़ा कम होता है, और जो लिक्विड स्टेट में जो होता है पार्टिकल फ्री मूव करता है और उनके पास ग्रेटर स्पेस होता है, इसीलिए वो जल्दी लिक्विड हो जाते हैं। देन आ गया आपका गैसियस स्टेट। हैव यू एवर ऑब्जर्व ए बलून सेलर filling a large number of balloon from a single cylinder of gas? Inquire from him how many balloons is he able to fill from one cylinder. Ask him which gas does he have in the cylinder. You can see in your surroundings that this type of balloons are being sold. We have observed that the gases are highly compressible as compared to solids and liquids. तो ये भी highly compressible होता है solid और liquid से। The liquefied petroleum gas, जिसको हम LPG बोलते हैं, cylinder that we get in our home for cooking, or the oxygen supplied to hospitals in cylinders is compressed gas. तो जितने सारे भी जो हम एलपीजी मिलता है हमको, जो घर में जो हम कुकिंग करने के लिए लेते हैं, और ऑक्सीजन सप्लाई टू हॉस्पिटल जो सिलेंडर हॉस्पिटल को दिया जाता है, इज कंप्रेस्ड गैस। कंप्रेस्ड नेचुरल गैस इज यूज्ड एज अ फ्यूल दीज डेज इन व्हीकल्स। तो सीएनजी जो है नाउडेज हम क्या करते हैं, उनको उनको हम अभी व्हीकल्स में यूज करने लगे हैं। Due to its high compressibility, large volume of gas can. So this was all about your story, and you can write in the comment section if you have any doubts. Please subscribe my channel and share among your friends. Thank you very much. All cylinder में हम उसको ट्रांसफर कर सकते हैं easily. We come to know of what is being cooked in kitchen without even entering there. तो हमको पता चलता है कि रसोई घर में क्या पका रहे हैं कि हम उसको स्मेल करके बता देते हैं। दैट रीचेस आवर नॉस्ट्रिल्स, जो हमका जो नोज है, नॉस्ट्रिल्स है, वहां तक पहुंचकर हमको बता सकते हैं कि व्हाट इज बीइंग कुक्ड इन आवर किचन। How does this smell reach us? The particles of aroma of food mix with the particles of air spread from the kitchen, reach us and even farther away. The smell of hot cooked food reaches us in the seconds. Compare this with the rate of diffusion of solids and liquids. Due to the high speed of particles and the large space between them, gases show the property of diffusion is very fast into other gases. तो यहाँ पे gases का थोड़ा ज़्यादा speed होता है diffusion में. In the gaseous state, the particles have the about randomly at high speed. Due to this random movement, the particles hit each other and also walls of the container. The pressure exerted by the gas is because of this force exerted by gas particles per unit area on the walls of the container. Then can matter change its state? जो मैटर होते हैं तो वो क्या अपनी जो स्टेट होता है वो चेंज कर सकते हैं? Let's see. We all know from our observation that water can exist in three states of matter: solid as ice, liquid as the familiar with water, and gas as the water vapor. What happens inside the matter during this change of state? What happens to the particles of matter during the change of the states? How does this change of state take place? We need answers to these questions, isn't it? Then effect of change of temperature. On increasing the temperature of solids, the kinetic energy of particles increases. तो जो solid का temperature अगर increase होता है तो kinetic energy of particle also increases. Due to the increase in kinetic energy, the particles start vibrating with greater speed. जो kinetic energy increase होता है इसीलिए वो particles जो होते हैं वो ग्रेटर स्पीड में वाइब्रेट होना शुरू हो जाते हैं। द एनर्जी सप्लाइड बाय द हीट, द एनर्जी जो सप्लाई होता है हीट के द्वारा, ओवरकम द फोर्सेस ऑफ अट्रैक्शन बिटवीन द पार्टिकल्स, जो पार्टिकल्स के बीच में जो फोर्स ऑफ अट्रैक्शन होता है वो हीट के द्वारा ओवरकम होते हैं। द पार्टिकल्स लीव देयर फिक्स्ड पोजीशन एंड स्टार्ट मूविंग मोर फ्रीली, जो पार्टिकल्स है वो फिक्स्ड पोजीशन में छोड़ देते हैं एंड द मूविंग और मूव क्या करते हैं, फ्रीली मूव होते हैं। A stage is reached when the solid melts and is converted to a liquid. The temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. The melting point of a soil is an indication of the strength of the force of attraction between its particles. The melting point of ice is 273.16 K. The process of melting, that is change of solid state into liquid state, is known as fusion. When a solid melts, जब solid melt होता है, its temperature remains the same. So where does the heat energy go? Dear friends, just try to give attention that some words that I'm not convincing you, I'm not giving explanation in Hindi because I think that it will be a large video, means lengthy video, so I'm trying to reduce this video. So if you have any doubts regarding that points, you can write in the comment section. I will make you understand. So let's move on. You must have observed during the experiment of melting that the temperature of system does not change after the melting point is reached. Till all the ice melts, it happens even though we continue to heat the beaker, that is, we continue to supply heat. This heat gets used in the changing the state by overcoming the forces of attraction between the particles. As this heat energy is absorbed by ice without showing any rise in the temperature, it is considered that it gets hidden into the contents of the beaker and is known as the latent heat. The word latent means the hidden. The amount of heat energy that is required to change 1 kilogram of a solid into a liquid at the atmospheric pressure at its melting point is known as latent heat of fusion. So particles in the water at the 0 degree Celsius 273 K have more energy as compared to the particles in the ice at the same temperature. When we supply heat energy to water, particles will start moving even faster. At a certain temperature point is reached when the particles have enough energy to break free from the forces of attraction of each other. At this temperature, the liquid starts changing into gas. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. Boiling is a Bock phenomenon. Particles from the bulk of the liquid gain enough energy to change into the vapor state. For water, this temperature is 373 K. 100 degrees Celsius is equal to 273 plus 100 is equal to 373 K. Can you define the latent heat of vaporization? Do it in the same way. We have refined the latent heat of fusion. Particles in the stem, that is the water vapor at the 373 K or 100 degrees Celsius, have more energy than water at the same temperature. This is because particles in the stem have absorbed extra energy in the form of latent heat of vaporization. So we infer that the state of matter can be changed into another state by changing the temperature. We have learned that the substances around us change state from solid to liquid and from liquid to gas on application of heat, but there are some change directly from solid state to gaseous state and vice versa without changing into liquid state. तो वहां पे भी कुछ सॉलिड से हम गैसेस बना सकते हैं, गैसेस से वो सॉलिड बना सकते हैं, लेकिन हम उसको बिना चेंज किए लिक्विड स्टेट में, बिना चेंज किए हम उसको बना सकते हैं. A change of state directly from solid to gas without changing into liquid state or vice versa is called sublimation. तो sublimation क्या होता है? A change of state, जो change होता है एक state का, जो change होना directly from solid to gas without changing liquid state, मतलब liquid से बिना change हुए अगर solid से gas होता है या gas से solid होता है तो हम उसको बोलेंगे sublimation. The effect of change of pressure. We have already learned that the difference in the various states of matter is due to the difference in the distances between the constituent particles. What will happen when we start putting pressures and compress a gas enclosed in a cylinder? Will the particles come closer? Do you think that increasing or decreasing the pressure can change the state of matter? Applying pressure and reducing temperature can liquefy gases. तो जो अगर हम प्रेशर अप्लाई करते हैं और टेम्परेचर रिड्यूस करते हैं तो वो लिक्विफाई गैसेस हो जाता है, वो गैस लिक्विफाई करता है. Have you heard of solid carbon dioxide? It is stored under high pressure. Solid CO2 gets converted directly to the gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. This is reason that solid carbon dioxide is also known as dry ice. Thus, we can say that the pressure and temperature determine the state of a substance, whether it will be solid, liquid और gas. तो यहाँ पे बताया गया है कि जो प्रेशर है, टेम्परेचर है, वो डिटरमाइन क्या करता है, whether it is solid, liquid or gas. Then next comes the word evaporation. Do we always need to heat or change pressure for changing the state of matter? Can you quote some examples from everyday life where change of state from liquid to vapor takes place without the liquid reaching the boiling point? Water, when left uncovered, slowly changes into vapor. Wet clothes dry off. What happens to water in the above two examples? We know that particles of matter are always moving and are never at rest. At a given temperature in any gas, liquid or solid, there are particles with different amounts of kinetic energy. In case of liquids, a small fraction of particles at the surface having a higher kinetic energy is able to break away from the forces of attraction of other particles and gets converted into vapor. This phenomenon of change of liquid into vapor at any temperature below its boiling point is called evaporation. तो अगर उसका हम नीचे रहेगा फिनोमेना ऑफ चेंज ऑफ लिक्विड इनटू वेपर्स एट एनी टेम्परेचर बिलो इट्स बॉइलिंग पॉइंट, अगर उसका बॉइलिंग पॉइंट के नीचे होगा हम उसको बोलेंगे एवापोरेशन. फैक्टर्स अफेक्टिंग एवापोरेशन. क्या क्या फैक्टर एवापोरेशन को? You must have observed the rate of evaporation increases with the increase of surface area. We know that evaporation is a surface phenomena. If surface area is increased, rate of evaporation increases. For example, while putting the clothes for drying off, we spread them out. An increase of temperature. With the increase of temperature, more numbers of particles get enough kinetic energy to go into vapor state. A decrease in humidity. Humidity is the amount of water vapor present in the air. Humidity water vapor का जो amount होता है जो air में होता है, the air around us cannot hold more than a determined amount of water vapor at a given temperature. If the amount of water in the air is already high, the rate of evaporation decreases. An increase in wind speed. It is common observation that the cloth will dry faster on a windy day. With the increase in the wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surroundings. How does evaporation cause cooling? वो कैसे cooling को cause होता है, मतलब उस कारण बनता है? In an open vessel, the liquid keeps on evaporating. The particles of liquid absorb energy from the surrounding to regain the energy lost during the evaporation. This absorption of energy from surroundings make the surroundings cold. What happens when you pour some एसीटोन नेल पॉलिश रिमूवर ऑन योर पाम? जब जो एसीटोन होता है, नेल पॉलिश रिमूवर होता है, अगर आप अपनी पाम में देते हैं तो वो क्या होता है? The particles gain energy from your palm or surroundings and evaporate, causing the palm to feel cool. After a hot sunny day, people sprinkle water on the roof or open ground because the layers latent heat of vaporization of water helps to cool the hot surface. तो हम पानी डालते हैं, अपनी ग्राउंड में पानी डालते हैं, अपनी छत में पानी डालते हैं. क्यों? कि जो गर्मी हुआ है उस पे पानी डालने से थोड़ा जो हॉट सरफेस है उसको थोड़ा कूल कर सकता है. Can you cite some examples from daily life where we can feel the effect of cooling due to evaporation? Why should we wear cotton cloth in the summer? During summer, we perspire more because of the mechanism of our body which keeps us cool. We know that during the evaporation, the particles at the surface of liquid gain energy from surroundings or body surface and change into vapor. The heat energy equal to the latent heat of the vaporization is observed from the body, leaving the body cool. Cotton, being a good absorber of water, helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation. Why do we see water droplets on the outer surface of a gas containing ice cold water? तो हम देखते हैं कुछ ड्रॉपलेट होता है कि जो आइस कोल्ड वाटर होता है उसमें बाहर कुछ जैसे कि ड्रॉपलेट्स होते हैं तो क्यों होते हैं क्यों देखते हैं हम Let us take some ice cold water in a tumbler. So we see water droplets on the outer surface of the tumbler. The water vapor present in the air on coming in contact with the cold gas of water loses energy and gets converted to liquid state, which we see as water droplets. So this was all about your this chapter, and if you have any doubts you can write in the comment section. I will discuss with you, and please subscribe my channel, and please share among your friends so that they can learn more. Thank you very much.